Okay, so we'll just talk quickly about what's going to happen each lesson. So every lesson will come, and this is going to be our notes book. We're going to be going through this at the start of every single lesson. Okay, so you come, you open it, and I want to start straight away so we use our time. We've got the checklist on the front of what we're working through. So we're working through chapter 5 and then chapter 7. All right, and the reason we're doing that is because when we get to the end of chapter 5, we're going to start our folio task. And there's some stuff from chapter 7 that I want you to do in your folio task, and then we'll finish off with chapter 6. Okay, so let's get into it. We're introducing you to some new terminology here. Firstly, we've got radian measure and we've got degrees. So the way I like to describe degrees, right, is like a pizza. Okay, that you've got a circle and we cut it into 360 pieces, where each degree is just one piece of the pizza. Okay, not great drawing, but I think you guys get the idea. 360 pieces. And the reason we use 360 is because the Babylonians used a base 6 counting system, and 360 is a very powerful number because you can divide it by 24 numbers. And that's all the numbers from 1 to 10 except 7. So it's very easy to manipulate. It's a good number that's easy to manipulate. So that's why we have 360. But it is arbitrary, so it could be 1,000 pieces, right? If you wanted to do it, if you wanted to change the definition of it. But that's what we've got. That's what we're using. And then we have this idea of radians, which is, you've seen that button on your calculator before, radians, or sometimes your calculator might have been in it and it's giving you the wrong answer. You're going, what's going on? So if you have a circle, you have a radius, don't you? You know, radius. Radius and radians. So we're seeing a bit of relation there. And 1 radian then is the distance around an arc of 1 times the radius. Okay? And the way we would denote that, of course, intuitively, is with a C for radians. So if you were to go 2 radii around the circle, like so if that's 1 radius and here's another radius, then you're going to have an angle there of 2 radii. Okay? Halfway around the circle, right, if you've got to go halfway around the circle, that's 180 degrees. That's actually 3.14159. It's actually pi radians. Okay? Halfway around the circle, 180 degrees, or in radians, it's pi radians. Remember, pi is just a number, 3.1459. And so then the whole way around the circle is 2 pi radians. And so we've got 2 pi radians is equal to 360 degrees. We've got a conversion chart there. If we're going from degrees to radians, we just follow the arrow and back the other way. And so what we're starting here with 5a is just some conversion. So let's have a look at the first one. We've got 75 degrees, we've got 31 degrees, and we've got 145 degrees. And it says convert the following to their opposite form. So we're starting with degrees and we're going to radians. And so we're going to go 75 times pi. And when we're going to radians, we multiply it by pi on 180. Alright, now I haven't brought my calculator along here, so I might rely on you guys a bit. So that'll be, we can divide both by 15. So 5 pi on 12. Alright, so if we have 75 degrees, it's equal to 5 pi on 12 radians. Okay, and so we can answer it like that, and that's it exactly, right? But remember, pi is just a number. And so if you were to put this in your calculator, and it might pop up like this, by the way, 5 on 12 times pi, they mean the same thing, okay? Because pi by itself is pi on top of 1, and if you were multiplying that, you've got top times the top, bottom times the bottom, gives you 5 pi on 12. So your calculator will spit it out like this. Now if you have that, and you press the surd to decimal button, 5 on 12 pi, okay, or F to D, everyone know that button? It's going to change it from a fraction to a decimal. And I've got 1.308. I'm going to write down the first 4 numbers, and then I'm going to round the 4th number. So that rounds up, so we've got 1.31. So here we can express it exactly. It includes every possible decimal place. Or here we can express it in terms of radians rounded to 3 significant figures. So when we say 3 significant figures, or 3 SF, it means write down the first 4 numbers and round the 4th one. Okay, 31 degrees, so that's going to be 31 times pi on 180. 31 pi on 180 in simplest form, because 31 is a prime number. We can't simplify that. And we'll just put that in our calculator to get it to 3 significant figures. I've got 0.5410, which is 0.541. Okay, the 0 doesn't change anything. And let's not forget our unit, C for radians. Okay, 145 times pi on 180. 29 pi on 36. Or to 3 significant figures, 2.530, which is 2.53 radians. Okay, then we're going back the other way. We're going to start with radians, and anytime anything's written with pi, okay, it's safe to assume that that is a radian measure. So it doesn't have the C there to tell you this is radians, but if it's got a pi in it, it's safe to assume it is radians. And if we want to convert from radians to degrees, we're just going to follow the arrow. We've got to multiply it by 180 on top of pi. So I might just break this one down in terms of how you could do it without your calculator, right? When we're multiplying 2 fractions, it's always the top times the top and the bottom times the bottom. So what we've got 3 times pi times 180 at the top and 2 times pi at the bottom. Okay? Pi at the top and pi at the bottom can cancel. We've got 3 times 180, which is going to be 540 on 2, and that's going to be 270. Okay, so I mean, some of these you might go, I don't know what 3 times 180 is, but it's something you could work out if you didn't have a calculator. Okay, so that's how we can break that down just by using the formula. 3 pi on 2 radians is 270 degrees. Okay, pi on 6. So excuse me, that was D. Here we got E. So pi on 6 times 180 on pi, that's going to be 30 degrees. And 2 radians. Okay, so we've got 2C, which means we're going to go 2 times 180 on pi. So that's going to be 360 divided by pi. Now remember, pi is just a number, so we've expressed it there exactly. Let's round it to a few figures. 360 divided by pi, I've got 114.5. It does say 114.59. Remember, we say we write down the first 4 numbers, and we round this one. 5 rounds up, so we've got 115 degrees. Excellent. So that's all we're starting with, 5A. So it doesn't look overly complex. I don't want to spend too long on it. What have we got written down on the checklist? There's 6 questions, but we might just spend 10 minutes now, and then you'll be able to do the rest of the homework, so we can have a bit of a look at 5B, where we start to apply some of these ideas. So finish taking these notes down. Are there any questions? Cool. Let's do it. Thank you.